So for today's problem, we'll be trying to solve the sine of 2 arc sine x. So the first thing we're going to look at is the argument over here in which it's x. So in another way we can find like how to start first is how x is the same as x over 1. And then if we look at this triangle over here and we assume that theta is over here, we know that since the arc sine opposite over hypotenuse is x, that means the opposite is equal to x, and the hypotenuse is equal to 1. And then so from there we try to find the b sine, and then we use our Pythagorean theorem in which x squared plus b squared equals 1 squared. We try to get b by itself, square root it, and then for b we get that it's equal to the square root of 1 minus x squared. So that's going to be the first step. And then the second step is that we also remember from our given information, we rewrite this sine 2 arc sine x is also equal to how we rewrite it as sine of 2 theta. And then from there we know that this one can also be rewritten as sine of 2u, and then we know that sine of 2u is equal to the 2 sine times cosine of u. And then we know from the cosine of u, or cosine of theta, it's adjacent over the hypotenuse. So we know that the cosine of u is equal to the square root of what we found earlier, which is 1 minus x squared over 1. And then we know that sine right here is equal to x. So if we rewrite that, the whole equation again, sine of 2 arc sine x is equal to the 2x times the square root of the cosine u, so 1 minus x squared. And then that's our answer. If we rewrite that more simpler, it's 2x 1 minus x squared. Then that is our final answer.